welcome back to the SaaS community channel, where we talk about problems, challenges, solutions, and discoveries when building software as a service, and we learn from each other. Today, I am learning from Gianluca, who is a software engineer at Aerosearch, previously at InfluxDB. I actually first became aware of Gianluca when he gave an amazing talk at DockerCon San Francisco, I think back in 2019, when we still had conferences and went to them and met a lot of people in the same room and were not worried at all about breathing the air. He talked about using Docker for testing, and I was so excited about having a software engineer give a talk about testing that I just remembered it for the next 3 years. And when Gianluca showed up on Twitter and offered to share his experience, I was like, let's do it. Happy to have you here.
Thank you. Thank you for having me. Yeah, I have to say that I'm not online that much since, all this pandemic. I took a break from public speaking, so I'm very glad to be here with you. And thank you for your introduction.
Yeah, I think it was serendipity. Right. So you basically took or were deeply involved in taking InfluxDB to become a managed service in the cloud. And now you are working on Aerosearch, which is also a managed service. Tell us in general, how is building a managed service different and what your customers generally experience that is different than just running your own database?
Yeah, so, many people now are looking at managed solution, and as everything, there are trade-offs. So the good part is that you can, you have support on your operations. So you don't have to look for your disk size, or you don't have to look for your CPU or memory. You can do what matters to you and leave that to somebody else. So what I was doing, what we are doing with Influx Cloud, and what we also have with Aerosearch, is a team that manage infrastructure, and also it deeply specialized on the software that it runs, because back then at Influx we had a team that was writing a database, and now I'm part of the team that writes database as well. So the operation team or the infrastructure team has access to the knowledge on the deep of the system. Something that even myself as a user, I don't have that knowledge on external databases. So sometimes they are just a black box. I know how they index, I know what the documentation tells me, but when production comes or outage comes, it's good to be able to knock the door and ask for help. Or sometimes you don't even ask for help.
Yeah, I was thinking the experience is actually way better if someone detects the problem and I don't even have to ask for help. You mentioned that I don't even have to do capacity planning. You said something about not watching my CPU.
Yeah, I mean, you have to watch for your bill at the end of the month. So that's almost the jump as a user that you have to metabolize. But at this point, with AWS and Google Cloud and all the other SaaS software and cloud providers, it's clear that we tend to simplify all the metrics that we used to watch as operators to a bill at the end of the month.
So it's completely serverless, and you auto scale. If I start having a bigger workload, you will charge me more at the end of the month, but everything will auto scale. I don't have to worry about how many cores you needed to add. That's kind of amazing. Yeah, it's very magical. By the way, not every managed service in the world does it, so it's kind of extra.
We at the time I was at Influx, we had the solution we had was made with tier. So you had to pick a tier, and when we knew that that you were going along to approach that, we were scaling or asking you to change the plan. With the new offer, it is way more elastic than what it used to be. But I also want to be clear that I don't work there anymore. So for me here, it's just an experience I want to share, that I think it's important when we build SaaS now, that way more people are doing that. So,
yeah, and I think for the user, it's obviously like the ultimate cool experience, because I don't think anyone loves doing capacity planning for their database.
Yeah, for example, something that I still remember has one of the, a very cool idea that we introduced at Influx was the concept of, we were sharing a tiny bit of metrics from our internal system to the customer. And that was, initially it was a way to empathize with the customer and communicate more. We call that co-monitoring. But in practice, moving forward, it really become a tool for the user to figure out how their behavior and their changes was impacting the use of the SaaS. So I think that's something that I don't see very often, but I would like to see more often. So even if you're not supposed to care about CPU or memory usage, having those metrics kind of makes you to empathize with the system a bit more, and you just approach that differently. So I really thought it was...
Yeah, and it can help you save money. Like if you see that a certain query spikes the CPU, you kind of know that it's going to spike your bills, and you can optimize the indexes. Like it's almost creating the right incentives. People who spend more time thinking about their queries and indexing will end up spending less money at the end of the month.
And when you run a SaaS, you also have like a support tier, and building this relationship with the customer also decrease, the amount of tickets that assistant.
You promised to tell us how things worked behind the scenes and how you evolved from a homegrown system into Kubernetes, and kind of what was pros and cons of each solution.
So when I joined, we had a solution that was custom made in Go, and it was kind of an orchestrator. I'm saying kind of because it was all made, so it had some rough corners or edges to figure out, but it was able to provision a request, and a request can be a customer required for a new cluster that is made of 5 CPUs of this size and a VLAN and load balancer. So it was part of a request of a user derived to rules that we had internally. So we knew that every cluster needed its own VLAN and its own load balancer for the various services. So we kind of provisioned all of them with the help of the AWS SDK, because back then.
So directly Go and AWS SDK, no Terraform, like literally.
No Terraform, nothing like that. So the cool, somehow I discovered that many of the techniques and the way we brought that orchestrator are the concept that Kubernetes use every day. And that was, somehow surprising based on my low experience on the topic. But now that I know a bit more, it's not well surprising. It's kind of why it's how you build those kind of systems. So we had, a reconciliation loop, and we made a plan on every request. And on that plan, we were continuously checking on the outcome. And as long as we were able to balance and, match the plan with the outcome, we were good. When something was diverging, we knew that we had a problem. So basically, we knew that we were expecting 5 AC2, healthy AC2. We were constantly looping over them, and if they weren't like planned, we were triggering an alert at the beginning, or we were trying to do some basic reconciliation, trying to recover from the failure. So that's really, if you go deep on the Kubernetes controllers, that's what they actually do. So yeah, it's definitely, it was probably, the abstraction wasn't that clear as the Kubernetes one, because Kubernetes is meant to be general purpose. The orchestrator that we had internally was meant to solve our problem, but it also had, now that I'm saying that, I realize that it's a trade-off. So the abstraction wasn't that clear, but also we had fewest abstraction. that in practice turned to a system that were smaller and easier to understand. So yeah, that's probably something that we have to pay when we write code. So there is nothing the right solution. There is a solution that works.
Yeah, on the other hand, the basic concept of an orchestrator that is doing a reconciliation loop, as much as it's obvious today, I don't think it was very obvious if you look back even 10 years ago, definitely not before that, where really things were very prescriptive. It was like, okay, do step X, do step Y. If anything fails, stop, and they said alert, but there was no idea of awareness of the end state and having a lot of multiple things that could be done to get to this end state. And yeah, I always thought that it was kind of something that Kubernetes introduced into our life, but
luckily I had in my team, I worked with a person that explained, that was coming from robotics. So he, saw that as obvious, that because, he told me once, like, this problem looks like a problem we had in robotics when we push a robot and we have to recalculate. So that's what really opened our minds and, enabled us to move from the if statement that you just, share, that is something that we had at the beginning, to a more elastic and dynamic solution that looked like a reactive plan. So a bit more reactive. So even if I'm simplifying and saying that we had a cloud without Kubernetes and a cloud with Kubernetes, there are different areas or version of that along the way. So definitely we started with something that was way easier, so made with a bunch of if statements, but at the end we got to having a plan, being able to build a plan and execute that continuously. That was cool.
Yeah, it's kind of one of the things that's really surprising, because the concept of reconciliation and really describing the end state was so powerful in infrastructure that it's hard for us to imagine that we ever lived in a different world. And I don't see it didn't go yet beyond infrastructure. People don't apply it to their application microservices all that much, but maybe that's the next step in software evolution, reconciliation everywhere. So you had a system. It was actually based on very solid principles. It probably worked for you for a while, and then you decided to move to Kubernetes. Why? It worked.
Yeah, I mean, it worked for at the scale that the company was. And when I think about scale, I'm not only speaking about the system, so how many ACQ we were managing and so on, but also the scale of the team and the lack of abstraction and an unclear API to interact with the system, and also the rise of containers kind of played a role. And also, as you may know, Influx also had a redesign in a new system, so it was part of a much bigger picture. So we decided to freeze or to slow down the evolution of the orchestrator to move to Kubernetes. And yeah, I have to admit, I don't really have a preference. Probably as a developer, I prefer more to work on the orchestrator, because there is a bit more challenge, or at least the challenge that I was looking for. But I also had the opportunity to learn Kubernetes deeply, and it really opened my the part of my life where I contributed the most to the community. And so it has its own benefit, and I'm also constantly jumping between operation and development, so I'm not really sure what I like most, so it's really hard for me.
Nobody really wrote the blog post on the SRE SWE pendulum and people who keep moving between those roles. But I think there is a lot to be said about people moving between those roles. Actually, when I think in retrospect, probably the strongest engineers I know did a lot of operations in various parts of their career and developed, as you said, kind of system sympathy.
Yeah, no,
You get to feel it for the poor CPU doing extra work when you write your code.
yeah. It's, I was recently debugging a bug with a sales engineer in Aerosearch now, and we were not able to. I coded the feature or the bug, so let's call it as you want. And he asked me a bunch of questions because he was trying my code, and we weren't really able to figure out the problem. So one of my colleagues just suggested me to add more metrics, to expose more metrics, more Prometheus metrics that I didn't, expose, because I tend to expose what I know that would be useful, but not really the internal state that much. So the feature was counting on bytes and removing bytes. So I wasn't exposing, for example, a few counters that I had in there. And the solution, or at least what helped us to figure out the problem, was just, there. I had the variables, I didn't expose them, and I just exposed them. So, and I think this kind of experience really rise when you are able to face both sides of the coins, when you are the one that runs the application, and when you are the one that develops the application. So if you don't do both, you definitely have a gap, or the feedback loop is way longer, and
you can see that engineers who work on production just write better error messages because they know they're going to have to read them at 2 a.m.
Yeah, they are also wiser on logs because they know they're spammy. So.
Exactly that. Although I heard that now one can deal with spammy logs with Aerosearch, so maybe this will. I feel life will be easier if I would be able to log a lot more and not worry about things.
Yeah, we are trying to do that. So.
So I have a question. Basically, you mentioned you kept on maintaining the homegrown system as you moved to Kubernetes. One of the issues that I ran into was that when you add a new feature, it's always a bit easier to add it to the homegrown. Like, it's already there. The new system maybe still, it will take a few months until it's even in production. So it could, and if they are delayed, it will delay your feature. How did you get engineers to stop writing code on the old system and move to the new one?
Yeah, I think for the time I was at Influx, it was easier because we also onboarded the idea to rewrite the old system. So for us was mainly like, okay, what we have is old or is almost done. The new one is what we're gonna focus on. So we kept compatibility with the API, so they were able to manage to move some of the customers, and I wasn't there, but we know that they also did another migration before, like way before that, so they had experience on doing those stuff. But yeah, it's definitely a challenge, but I think what really made a difference was having an API that was compatible. And those days where interoperability means everything, it shouldn't be impossible to say, obviously you can move all the customers without telling them and look like magic. It's not magic, but if you plan for that, you can probably do good things.
So you made it look magical for the customers, and what about the internal developers who used to deploy here and deploy there? Did it feel magical to them, or was for them it's like, okay, got to learn Kubernetes now?
Yeah, no, that's probably one of the things I learned. So the friction with the developers was real. So we had database engineers that usually are they do a really specialized work, so they tend to have specialized tools. So really having them on board on Kubernetes wasn't easy or wasn't obvious. So the training was important. Back then I was reading Kubernetes Up and Running from Kelsey Hightower, and I just proposed to get one of those books to all the company and all the engineers to just get a good vibe. And I think it's a very good reading because I find it very close to documentation somehow. So I feel that learning from that, I was able to find a lot of similarities with the documentation. So it's almost like a booster that brings you to the documentation somehow. So I really find that practically useful to learn Kubernetes.
Yeah, no, that's a great tip in general. If you have to take a large number of engineers and really force a change on them, doing a book club is not the worst thing one can do, I guess.
Yeah, and let me think. So yeah, definitely, training and was useful, and also we had an SRE team that kind of acted as a bridge between what was the old way and what was the new way. But I have to say that at the end of the story, it was almost like, okay, give me your containers, and in the way you gave me the container before, you will give me a new container that we ship that. So it wasn't really changing too much from what concerns building the software. The operation was totally different, but from a developer perspective, not that much. Probably it was more scary in terms of, oh, this company is going to onboard Kubernetes, what's going to happen to me? They were scared on that sense. Obviously, a lot to learn, a lot to look at, a lot of changes, but in practice, you can be as transparent as possible with the developers as well. Mainly because I agree a lot with what you said before about all the reconciliation loop that should be applied not only to infrastructure, but can be applied to microservices and stuff like that. So it really improves reliability everywhere somehow. So it's a mindset that the developer had when they write software. Maybe it's not clear, it's not well defined as it is in infrastructure, when you know that you have those loops and Kubernetes does that, but it's there. So yeah.
Yeah, one of the things that I discovered when I moved to Kubernetes, the abstractions are very good in the sense like there's a lot of uniform abstractions that you can kind of count on, but it felt like there is a lot of magic going on behind the scenes. Like you do kubectl, delete, or like there's actually a lot more going on than you realize. Any interesting learnings, surprises that are kind of like, oh, this is totally different when you move to Kubernetes?
Yeah, I think keeping the peace in your production environment is complicated, almost as it is with countries. So you have to be patient and you have to be diplomatic somehow. So yeah, there is really a lot. There is really a lot going on. Under the hood of Kubernetes, even if the abstraction is just a CRUD, so update, delete, get, leave. There is a lot more going on, and that's why we have so many fields. So when you create a pod, you have a YAML that is that.
Yeah, I know, right?
You can really fit that in your screen. So that's the reason. And knowing all those bits can be complicated. And sometimes what scares me most is that you don't need to, there is no way you can know them all when you start, but you are going to learn them when it's too late or when you have an hour.
Oh, yeah.
So this is really what, but I think that's kind of the normal. It happens with all the systems that are a bit more complicated than the one I can write on my own. And even the one I write on my own can be scary, has Kubernetes. So I want to be clear with that. But yeah, I mean, the way I think what helped me to do the switch in my Kubernetes experience was writing a custom resource definition. So when I wrote or one controller. So if for the people listening who don't know, so Kubernetes gives you a few hooks that you can use to write a resource that is not the one that you have by default. So by default, you have deployment, pods, ingress, and whatever. You can write your own one, and it can be whatever you want. So it can be even event in your calendar. It doesn't need to be infrastructure. It can be whatever. And that's kind of brings back to the point you made about, it's not just for infrastructure. But writing a custom resource definition gives you requires to write a controller, and the controller is the reconciliation. So writing your own one kind of, or deeply understanding how they works, gives you the answer to a bit of the craziness that you get. So all the timing issue kind of become a little bit more, they kind of have a sane explanation, but it's still, it is a complicated piece of software, and control is not easy to gain.
Yeah, and I think that was exactly my big Kubernetes lesson. I literally remember when the realization dawned on me that when I do a shutdown, like kubectl delete for a Kafka broker, it takes down the broker. It also needs to take down the load balancer that leads to that broker, and it does them asynchronously. So it could happen that the load balancer is gone and the broker is still up. It's a leader of partitions that can no longer be accessed. I don't know if they're explicitly written anywhere.
I mean, I see a lot of correlation with other systems. I mean, when you take Elasticsearch and you do your first indexing, you're gonna get it wrong, and you're gonna learn it when you have too many documents and you can't query them anymore. So it's too late to know.
Yeah, exactly that. And then there's solutions, but I feel like it would have been good to have more. I think a bit more on, here were the problems and here are several good solutions, and basically, how to get a bit more control in Kubernetes. As you said, like you have to write your own resources if you need to have more control over things.
Yeah, I think it's really, for me, it was a really good exercise to really, connect the dots with the system.
Yes. What was your big, like, oh my God, I had no idea it's like that?
Let me see. I think, when at the beginning, everything starts with an apt install. So you get everything you need and that's it. And it looks like a gigantic single binary. But at some point we had too much pressure on the API server, and you start to realize that there are 20 components that are behind the API server. There are 20 containers.
Oh, yes.
There is the scheduler and the proxy, and all of those plays a role. So that was definitely a first, challenge that I had to figure out ongoing. So what was actually failing on why the latency was so high? So that was definitely, complicated at the beginning, but as soon as you get to the documentation and you figure out the architecture diagram, you have to spend a month on it, but at least it's there. So,
I think that's the other thing about not even migrating to Kubernetes, adopting Kubernetes, unless you have a lot of prior experience, you kind of need to take your time. Like, because you never know when you'll run into something surprising as a Kubernetes or something cloud specific implementations. Like if I had to move, I remember when we only ran in AWS, at some point we were GCP, Azure. There were new learnings in each one. I'm not sure if you had this multi-cloud experience, but you kind of need to prepare for surprises in multiple steps in the journey.
When we moved to Kubernetes, one of the goals was to become multi-cloud, and at the end we were multi-cloud, and they are multi-cloud. So, I mean, the only things that stays the same is the API, but under the hood, they do different interactions. So, you need to be, as you said, you need to be ready for, different behaviors, unexpected different behaviors.
So, I know if I was starting today cloud from scratch, which by the way, I kind of am, would you tell me to start with Kubernetes, or should I write my own Go controller? I have to admit that my own Go controller sounds a bit tempting.
I think you should do your own one. So, I keep reading from Honeycomb and the experience they have, because I don't know if it's still the case, but I think they don't use like Kubernetes. They just do, they build MEI on AWS and they ship them. And this is almost like, the experience you get with containers. So I don't want to be, I don't want to start a flame here, but really under the hood, you have a zip file and you go that to the hypervisor and you get your VM working. So usually like time is not a concern that, you don't really, bootstrap starting time is not really a concern that has to be strict to 10 milliseconds. So you can wait for, 3-4 seconds. AWS is way better than what it used to be, for example. And having a reconciliation and, a binary, an orchestrator you can control, I think really is great as a start, but not really as a start only. So I'm really not that. So if you have the right knowledge, Kubernetes can be avoided, but also you need the right knowledge for Kubernetes.
Yeah,
so it's a bit, everything is a trade-off, but at least for my view, I really enjoyed the control that the custom orchestrator gave us compared with Kubernetes, and the bug that we had with the orchestrator, I feel strong saying that they were almost the same as the unknown that we had with Kubernetes. So I don't really feel bad saying that. So and I like to write code, I like to use Kubernetes, I like Docker, whatever. So I use all of them, and I spoke many times good way, but demo, and so it's not really. It's really just, speaking with the experience and what I like most.
Yeah, and I think something that's worth saying, both of our experience has been running stateful data systems on Kubernetes, which from my experience, Kubernetes has been fairly transparent that while they have stateful sets, they do not, it's not something that they deeply love, and that's not Kubernetes's, not where it really shines. And you really look at every bit of documentation, and the example is always Nginx. And Nginx is awesome. I'm a big fan, but it's famously stateless. So you kind of it definitely feels like if you're running something stateful with Kubernetes, you're slightly going against the current, and you're going to bump into more rocks, and it's not going to be as smooth as if it's an application server. I would feel a bit easier running it.
Something I want to share is that I have the feeling that many companies are onboarding Kubernetes to tell that their code runs on Kubernetes, and it's a bit do
customers even care though?
So I don't know if they don't care or not, but if the company are successful, probably they care somehow, so I can tell, but it's not really. When my mind translates write code that runs in Kubernetes, is like write more resilient code. And that's something that we should do either way,
anyway,
whatever it runs.
Yeah.
The fact that Kubernetes gives the impression that you write code is more reliable means that for some reason it caused that reliability difference. So I don't know. I can't really tell, but I'm all in writing better and more resilient code, but you don't really need to say that you're writing code that runs on Kubernetes.
Yeah. I think it's because Kubernetes managed to get conflated with cloud native. And I definitely feel like cloud native implies more reliable code, because when you run your code on someone else's infrastructure, you lose illusion of control. And I really think that what you lose is an illusion. You never had a lot of control over when will things go down, but there's no longer someone you can fire if something goes down. So you feel like you lost control, and now you have no choice but to write very resilient code.
I didn't have the opportunity to try that myself, but something I really want to do at important scale at some point will be to don't really work deeply and strongly with the spot market in the Kubernetes, in the cloud land. So for the people who doesn't know, many cloud provider has an internal kind of market for virtual machine or AC2. I speak AWS word because that's my provider of choice usually, but I think it applies to many different ones. So you can trade your VMs and they get shut down when the price goes up and so on. So that's good for cost, but it also makes your code more reliable because you never know when the market is going to change. So maybe it's fun, who knows?
Yeah, and that brings back to the idea that we discussed in the beginning, that there are actually market mechanisms that reward writing code in certain ways, being maybe more efficient or more reliable. I kind of love the idea that if you have more resilient application, you can get kind of market arbitrage out of the spot market. Yeah, if you ever try it, come back to the show and tell us all about it, because this is really, really cool.
Yeah, well, you know.
Yeah, you could do it at scale. Now I'm going to think about it all day, I'm telling you, because it
does
sound like something that you should be able to get good mileage out of.
Yeah, just drop me a message if you end up with something good. I want to know.
Cool. So anything else, people starting on the adventure of moving to Kubernetes, like last bit of advice for everyone?
Yeah, I think I never really had the opportunity to play with the chaos engineering world, but I learned a lot from the outages I had, and we had the opportunity to have a system at scale, and in somehow, even if that scares many people, including myself, it also enables you to learn at a fast rate. So if you learn at a fast rate, you get stronger and you are more confident with Kubernetes. So having a Kubernetes that never fails, or that looks like it never fails, you are probably not stressing that too much. So stress it somehow, figure it out. It can be like switch it on and off randomly or whatever. It doesn't need to be complicated. Obviously, try to be not destructive to yourself or to your system, because it's not good. But a very good way to learn is to operate the system. And if your system is too quiet, add some noise, because it's healthy for you.
Yeah. And it can actually, chaos can be like, people tend to make it huge project. We had an engineer that overnight just wrote a controller that continuously restarted a specific machine. Yeah. Like nothing big, it just continuously, I think it actually continuously rolling restarted the cluster. So just shut down the cluster, started it continuously. We learned so much from just, I think, 24 hours of this thing running, not in production, on our test system. Yeah. We still learned so much from it. So yeah, deeply, deeply recommended. What's your recommendation from learning from an incident? Like, let's say something terrible happened, we finally managed to recover, and we really want to maximize the learning out of it, because as you said, this is really when the good stuff happens. What's your advice, sir?
My advice is also an advice for, it's also good for myself. So you should write the result of your outages and share that publicly. So I spend hours reading about postmortems from everywhere I can find them. Yes. And that's good for me, because it's not the same, but it kind of gives me the feeling that I'm learning from somebody else's pain time. And as I said, I learned a lot during the outages we had, because that's when you need to solve the problem no matter what. There is no shortcuts. And so when I write one, you have the opportunity to learn more, because you summarize it, you figure out the timing, you highlight that in some way. So that's good for yourself, and sharing also gives to other people the ability to learn. So it's a enforcing loop that really helps. So my two cents are just write and share.
I absolutely agree. And the idea with sharing publicly, I noticed, just like in open source, it causes engineers to push themselves extra bit harder, because if it's an internal report that you send to your manager, you can basically ask like 2 whys, and they say, well, I don't know, something weird happened with the network. But if you're going to put your name on it and the entire world will be able to Google and see, you usually do an extra investigation and say, oh, and when I looked into the network, I discovered that the DNS, the Kubernetes controller, like you learn a lot you force yourself to learn a lot more because you don't want to kind of like, well, something weird with the network.
Yeah, and it proved to be, if you run a company or for whoever runs a company, it proved to be a good, way to hire engineers. Because, if I know that a team was able to figure that out, I want to be part of it. So
exactly that. I've been trying to get more engineers to write postmortems in public forever. Turns out that engineers don't want to spend time writing, they want to spend time coding. And that product managers and marketing are like, but what if we give the wrong impression to customers? It's a hard thing to pull off, but I completely agree that it's super effective if you do it. So thank you so much for coming on the show and sharing all this kind of interesting and hard-earned knowledge with us.
Yeah, thank you for having me. It was great. And yeah, thank you.